Okay, let's take a look at section 3.3, which is on dividing polynomials. We've talked earlier in the course about adding and subtracting and multiplying polynomials, but now we're going to talk about dividing them. And so the first thing I want to do is remind you of how to do long division. You probably haven't done much of long division since maybe elementary or middle school. So I want to go through just the steps of long division with some numbers first. So the first sort of mini example we're going to do here is 6,283 divided by 5. And if you remember when you do long division, you want to take what you're dividing by. So in this case, the number 5, and we're going to put that in front of the division bar, and then the number that's actually being divided is what goes inside the division bar. And there's a sort of a 4-step process you want to follow, and that's the divide, multiply, subtract, and bring down. So first we're going to divide. So we're going to take 5 and we're going to divide it into 6. In other words, how many times does 5 go into 6? And that would be 1 time. And then we're going to multiply. 1 times 5, of course, is 5. And then we're going to subtract. So I'm going to subtract the 6 and I get 1. And then we're going to bring down. B stands for bring down, so we're going to bring down the 2. And then we're going to repeat the process. How many times does 5 go into 12? That would be 2 times. 2 times 5 is 10. Subtract, we get 2, and then we're going to bring down the 8. 5 goes into 28 5 times. 5 times 5, of course, is 25. Subtract, we get 3. We're going to bring down the 3. And then 5 goes into 33 6 times. 6 times 5 is 30. Subtract, and we get a remainder of 3. So in elementary school, your teacher might have said, write 1256 and then a big R3. We're going to, instead of using that R notation, we're going to write it as a fraction. So we have 1256 plus 3 divided by what you were dividing by, which was 5. In other words, 3 parts out of a whole of 5. So 1256 and 3/5 is what our answer would be there. So we're going to use that same process with divide, multiply, subtract, and bring down to divide polynomials using long division. In example 1, they're asking us to divide the polynomial x squared plus 10x plus 21 by the polynomial x plus 3. So I'm going to set it up the same way. I'm going to put x minus 3 in front of the division bar. And then underneath the division bar is what we're dividing, the x squared plus 10x plus 21. And we're going to start with the divide step. And all I need to look at is the x. I don't even have to worry about the 3. Just ask yourself, x goes into x squared how many times? In other words, what would I multiply x by to get x squared? And that would be x. Now, I'm going to put the x above the 10x because I like to keep terms with the same degree lined up. So I've got x. We're going to multiply now. X times x is x squared. And then I have to distribute that. So x times 3 is 3x. So when you do the multiplication step, you got to distribute that. Okay, then we're going to subtract. Now, the biggest thing students forget is when they subtract on the subtraction step, that subtraction has to be distributed to both of those terms. So I'm going to put parentheses around the x squared and the 3x. So then we have a negative x squared and a negative 3x. So you notice the x squared and the negative x squared, they zero out, right? X squared minus x squared is 0. That's what you want. You want that first term to zero out. If they don't, then something's wrong with what you did back here. 10x and negative 3x gives me 7x. And then we're going to bring down. So bring down the plus 21. Now we're going to repeat the process. X goes into 7x how many times? In other words, what would I multiply x by to get 7x? And that would be 7. I'm going to put plus 7 up here. And then we're going to multiply. 7 times x is 7x. 7 times 3 is 21. And then we're going to subtract. Don't forget your parentheses because that negative, remember, has to be distributed. So the 7x becomes negative. The 21 also becomes negative. You notice what happens here. We have 7x minus 7x cancels out like they should. But we also have 21 minus 21, which means we don't have any remainder. Remainder is 0. So our solution, our quotient, is the x plus 7 that we had up top. All right, let's take a look at example 2. So we're going to use long division again. So we're dividing the polynomial 5x cubed plus 6x to the 4th minus 5 plus 3x. We're going to divide that by the polynomial 3x squared minus 2x. So let's go ahead and get this set up. Now, there's a couple of things here I want you to notice. you notice that the first polynomial that they gave us is not written in order. We always want to write these in descending order. So if any of the terms are out of order, really in either polynomial, go ahead and put them in descending order. So let me go ahead and take care of the 6x to the fourth term. I'm going to write that first. So we have 6x to the fourth plus 5x cubed. So I'm putting these in descending order. Notice that there's no x squared term here. That's important. So if any term is missing, what we're going to use is what's called a placeholder. So instead of x squared, because there is no x squared term, I'm going to put plus 0 x squared. Don't skip that placeholder step. You'll see why in a second. That's going to make things easier for us. And then plus 3x and minus 5, going all the way down to the constant term. Now what's being divided? 3x squared minus 2x. You notice the constant term is missing there, so I need a placeholder as well. So on the outside, I'm going to have 3x squared minus 2x plus 0. And I know it may seem a little silly why we're putting those placeholders there, but it's going to keep everything lined up for us, and it makes it easier to keep track of all your terms. So use placeholders if anything's missing, even if it's that constant term at the end. So let's go ahead and start. We've got 3x squared divided into 6x to the fourth. In other words, what would I multiply 3x squared by to get 6x to the fourth? And that would be 2x squared. So I'm going to line that up above the x squared term. So 2x squared times 3x squared is 6x to the fourth, and that's good because you want those terms to match. 2x squared times negative 2x is negative 4x to the third. And then 2x squared times 0, of course, is 0x squared. So now we're going to subtract. Don't forget the parentheses. So let's change all the signs. So the 6x to the fourth becomes negative. The 4x cubed becomes positive. And the 0, of course, doesn't really change sign, but we'll put a negative there. 6x to the fourth minus 6x to the fourth, those are gone. 5x cubed plus 4x cubed gives me 9x cubed. 0x squared minus 0x squared, of course, is just 0x squared. And then we're going to bring down the next term, which is 3x. Now let's repeat the process. 3x squared times what gives you 9x to the third, and that would be 3x. So I'm going to put plus 3x up here. 3x times 3x squared is 9x cubed. 3x times negative 2 is negative 6x squared. 3x times 0, of course, is 0x. So we're going to subtract, distribute the negative sign. 9x cubed becomes negative. 6x squared becomes positive. 0x becomes negative. Doesn't really matter because it's 0. So the 9x cubes are going to cancel out. 0x squared plus 6x squared is still 6x squared. 3x minus 0x is still 3x. And then we're going to bring down the minus 5. And then can we go one more time? So basically, how do you know when you're done? Well, if you can multiply that first term up here by something to get this first term down here, go ahead and do that process. If you can't, then you're done and what's left is your remainder. But we can multiply 3x squared by what to get 6x squared, and that would be positive 2. So we're going to have 2 times 3x squared is 6x squared. 2 times negative 2x is negative 4x. And 2 times 0, of course, is 0. We're going to subtract, use those parentheses. The 6x squareds will cancel out, or that'll become negative. 4x will become positive, and 0, we'll just put a negative there. 6x squared minus 6x squared, those go away. 3x plus 4x gives me 7x, and negative 5 and 0, of course, is negative 5. There's nothing else to bring down. Notice that I can't multiply 3x squared by something and get 7x, at least not something with a positive exponent. So that means that this is as far as we can go, and 7x minus 5 becomes our remainder. So how do we write our final answer? So we've got 2x squared plus 3x plus 2, and then we're going to take the remainder. So we're going to do plus 7x minus 5 divided by what we were dividing by in the original question, the 3x squared minus 2x. And I'm going to leave off the placeholder. It'd be okay if you left it there, but I'm going to take it out because we really don't need it. And so this would be our quotient. Now the next question, they're asking us to divide using a technique called synthetic division. So synthetic division is another type of division, but it's a special type that can only be used when you're dividing by a linear factor, like x plus a number, or x minus a number. That's the only time you're going to use synthetic division. So notice that was different than the ones we were doing in the last couple of examples. Actually, we could have used synthetic division for the first example because we were dividing by x plus 3. But we could definitely not use synthetic division for the second example because we were dividing by a squared term, a quadratic term. So in this example, we're going to use synthetic division because we're dividing by the x plus 2. So the problem is 5x cubed plus 6x plus 8 divided by x plus 2. And the way you're going to start this is we're going to have a box. It seems a little silly here to have this box on our paper. We're going to have this little half box sort of thing, and we're going to put a number in here. And the way we determine what number we're going to put in here is the term we're dividing by, the x plus 2 term. Think about if you were to find the 0 that corresponds to that term by setting that equal to 0, we would get negative 2, right? So negative 2 is the number that goes in this box. A quick way to remember it is it's just the opposite of whatever that sign is. It's x plus 2, we're going to have a negative 2 in the box. Now, across the top here, we're going to put the coefficients for the polynomial that's being divided, and we still have to use placeholders if anything's missing. So I'm going to start with the 5. Notice that's the x cubed term. There is no x squared term, so I'm going to put a 0 there as a placeholder. 6x, so I'm going to have 6 for the next term, and then 8 for the constant. You're going to leave a little space on your paper, like leave a row of space and then draw a line. And then here's the algorithm we're going to follow every time we do synthetic division. First, you're going to bring down the 1, and then you're going to multiply. Negative 2 times 1 is negative 2. Then we're going to add 0 and negative 2 is negative 2. Then we're going to multiply. Negative 2 times negative 2 gives me 4. Then we're going to add 6 plus 4 is 10. Then we're going to multiply. Negative 2 times 10 is negative 20. And then we're going to add 8 and negative 20 gives me negative 12. So my solution is, since we're dividing or in this case, we're dividing a cubic function by a linear function, that means we're going to have a quadratic, an x squared, as our answer. So in other words, this 1 corresponds to x squared. This is like your x squared term. They always go down by 1 degree from what you started with. Minus 2x is the next term, plus 10, and then the negative 12 is our remainder. So since it's negative, I'm going to put minus 12 over what we are dividing by, the x plus 2. And that's going to be our final answer. It seems a little tedious, I think, the first time you learn this, but once you get used to this, this technique of using synthetic division, I think you'll find it's much faster than long division when we can use it. So let's try another one and let's take a look. So we're dividing x cubed minus 7x minus 6 by x minus 3. So first of all, think about what number is going to go in our little half box here. So we have x minus 3 is what we're dividing by, so I'm going to put a positive 3 here. And then we need our coefficients for the polynomial we're dividing across the top. X to the third, the coefficient is 1. There is no x squared term again, so I need a 0 as the placeholder. And then negative 7, and then negative 6. Leave a gap on your paper, and then bring down the 1 first. So we have 3 times 1 is 3. Then we're going to add 0 plus 3 is 3. 3 times 3 is 9. Negative 7 plus 9 is 2. 3 times 2 is 6. Negative 6 plus 6 is 0. So this time, that 0 means I have no remainder. So what's my polynomial? Well, we started out with x cubed, so the first term is going to be 1x squared, because it goes down by 1 degree, plus 3x plus 2. And since there's no remainder, that's it. That's going to be my final answer, my quotient. This last example, it says to use the factor theorem to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of the corresponding polynomial. F of x equals 2x cubed minus 3x squared minus 11x plus 6. Now, we're going to use synthetic division to figure this out. The factor theorem basically says, in a nutshell, that if we divide the polynomial by the 0, the 3 that they gave us, what we get left is a factor of the original polynomial, and we can use that remaining factor to solve the entire equation. It's not as complicated as it sounds. First of all, we need to figure out what number is going to go in our box here. So remember that we said earlier that the number that goes in that box is actually the 0 that you get when you solve this little expression. So like when we had x plus 2, we used -2 because that was the 0. In this case, they didn't give us a factor. They gave us the 0 itself, and that was 3. So I'm not going to change the sign like I did earlier. Whatever that, if they give you that 0 or that root, that is what actually goes in this box. So I'm going to put a 3 here, and I'm going to put the coefficients for the polynomial across the top. So we have 2, -3, -11, and 6. And we're going to leave a space and draw the line. Now, since we know that 3 is a 0 of the polynomial, we should get 0 as our remainder, and that's how we're going to solve the entire equation. If we don't get 0 as our remainder, something's wrong with our synthetic division. So the process, though, is the same. I'm going to bring down the 2. 3 times 2 is 6. -3 plus 6 is +3. 3 times 3 is 9. -11 and 9 is -2. 3 times -2 is -6. 6 plus -6 is 0. So that's a good thing, right? That means that we got 0 as the remainder, which is what we said should happen. So what's remaining here for our polynomial? Remember, it was a cubic polynomial. This goes down by 1 degree, so this is 2x squared plus 3x minus 2. Now to solve this, to find the other solutions to the equation, we're going to set this equal to 0. And because this is a quadratic, we can solve it using techniques we learned back in chapter 1 for quadratic equations. We could use the quadratic formula, however, this will factor, and I will keep them simple in class. I'll make sure whatever I give you here does factor. So if we break this down, we need a 2x and an x to give us 2x squared for the initial term. We need to get 2 as the last term, so that means my factors have to be a 2 and a 1. So let's see, if we put the 2 here and a 1 here, I think that'll work. We just need to figure out the signs, which one's positive and which one's negative. We want the middle term to be positive, so that means the larger term needs to be positive. So in other words, 2x times 2 would give me 4x. So if I make that a +2 and I put the -1 here, the inner term is -1x, right? The outer term is 4x, the inner term is -1x. That gives me +3x. So now remember the factor, zero factor property that says we can just set both of these equal to 0. So I'm going to get my solutions. I'm going to add 1. I get 2x equals 1. So x equals 1/2. Over here, I'm going to subtract 2. So I get x equals -2. And then don't forget, you also had the 0 they gave you in the beginning, which was x equals +3. So our solutions to the original equation that they asked us to solve, this one up here, is 1/2, -2, and +3.